Flack math! Give me some math and I'll give you some flack. Flack math!
Symbols of inclusion. So, what's this? Tissue box. Okay. Does anyone call it Kleenexes anymore? Now, this is in fact the brand Kleenex. But when I say, can I have a Kleenex? I don't mean if I don't have the brand Kleenex, then I don't want it. I just want a tissue. What about that thing that you throw like this? What's that called?
Frisbee.
No. Well, now they call it a Frisbee, but that is actually a throwing disc. But Frisbee is a brand name. Now they call all throwing discs Frisbee. Okay, let's see. What's something else that you can think of? I can't think of anything else. But anyway, when we say parentheses, we don't have to mean these. Okay, even though those are parentheses. So when I say this, parentheses, I could mean like these guys. I could mean like these guys. I could even mean like the absolute value thing. Could mean the division bar. But these are all symbols of inclusion. So we use different types so our eyes don't get wiggy. All right, so if I wanted to do this, 5 times that's confusing as poop right there. Okay. So what we do as a better way to do is we use different kind of symbols of inclusion. And then we can it's easier to keep track of what's happening here. That's a little bit easier to read. Okay. Does anyone use Excel? Like a spreadsheet? So they just use parentheses, but they do different colors of parentheses, so it's easier to keep track of which parenthesis goes with which parenthesis, okay? So it's like quotation marks. You can't have one without another. You can't just have one side of a parenthesis. So this is confusing. This means the same thing. This is not wrong. It's just harder to read. So we use different symbols of inclusion. Okay, so these are actually called parentheses. So when we talk about our order of operations, please excuse my dear Aunt Sally. So the P stands for parentheses, but what it's really referring to is all symbols of inclusion. Okay? What are these called? Starts with a B. Brackets. All right, what are these called? Starts with a B. Braces. What are these called? Oh, that's absolute value, right? And this guy is just a division bar, but it's a symbol of inclusion because you have to do everything on top and everything on bottom, and then the last thing you do is divide. Okay, so it does keep them separate. It keeps this all included as one thing and this one thing, and then you divide at the end. Okay, so we're just going to try a couple problems. So when you have parentheses inside of parentheses, you have to do those inside parentheses first and work your way out. Okay, can you handle it? Let's try. See if you can do this one. Ready, go. This is kind of easy, but you guys can handle it. Oh, maybe I'll make it easy. I mean, you can do a negative number if you want. Let's do that. 50 minus that. All right, you still have your hand up, Hunter?
30.
Okay, so I tricked you. So
Oh yeah, you changed the
I
number.
did change it.
I
So
know.
what's 50 minus all that?
Is that -5?
Yeah, minus 5 there.
Oh,
10 minus 5.
I thought it was 10 times -5. I was
Yeah.
so confused. I was like,
All right, what do you got, Hunter?
25.
Okay, so first things first, do that guy first. So if you need to rewrite it, do it. That was a sneeze. So. All right, so one step at a time. What's next?
25.
This guy right here, right? So we're going to rewrite that as 25. So this is still 50 minus 25. Now you could do that all in your head. That's fine. But remember, when you take a test, anything like that, you're dumber when you take a test. So be careful. So final answer, 25. All right, you want to do another one?
Not really.
What?
There.
You said no.
I have a question.
Yes.
Don't forget the examples we've done first. Will we get a problem set point?
Yep. I'm going to give 2 problem set points to one who gets it done first, and 1 problem set point to people who just get it done right. Okay? All right, here we go. Ready?
My thing's not
And
working.
you can do the chat if you want, Avery. Nope.
Let me make another one.
Yeah, you gonna write it down? You gotta show me. Are you don't have paper? It's not that. Write it out. Oh, I'm stumping you. My goodness. Oh. Where's your paper? You got some?
I just didn't.
Nope. Looks like I picked a tough one.
You dropped your pencil as well.
That was my
Oh. Someone formed my pencils.
Okay. Okay. I don't know who got it first, but you guys got it. Anything from Avery? Yes. Avery got it too. All right, the answer is 4. Let me give you some points here. 1 second. So Avery, Marin, and Patty. Okay. Patty, you're at 152.
Wow.
Whew. Avery, 139. Marin, 145. Goodness, you guys are on fire. All right, what do you do first? What's the innermost symbols of inclusion? Adeline?
Goes to like
Adeline?
the
Yeah.
absolute value.
Okay, so what's 4 minus 6? -2. So what's the absolute value of -2? Do you remember how to find the absolute value? What is it?
It's 2.
It's just 2. It's basically, if it's negative, make it positive. If it's positive, leave it alone. So that's 2. So everything else, I'm going to write the same. So 12 minus parenthesis 8 minus 2 plus 2. So far, so good? All right, now what? Yeah, we're still inside these parentheses. So now we can do this. What's that going to equal?
4. If every day.
No, do you know why you said, a lot of people said 4? Because you don't do addition before subtraction. Addition and subtraction, you just go left to right. All right, so a lot of you did that instead. 8 minus 4 instead of 8 minus 2 plus 2. See how that's tricky? That's why order of operations, a lot of math teachers I've heard are teaching that you do addition before subtraction. I don't know who they are as a person, but they need to be fired, okay? They should not teach math. So if you were taught that by another teacher, oh, it could be your mom, I guess. So don't tell her I said that. But we should fire your mom if she did that. So addition doesn't come before subtraction. Subtraction and addition are the same operation. You go left to right. Yes?
My dad would correct his teacher if they did that.
Well, that's
And
good.
then he'd just go right back to sleep and still have an A+ in the class.
Yeah, sounds right. Okay, so go left to right. 8 minus 2 is 6. Plus 2 is back up to 8. So that's 8. So then you have 12 minus 8, which is 4. Okay. So far, so good? So the only thing that I think stumped most of you was that dumb little, it just felt like you should do that first for some reason. But no, it's all left to right. Okay, let's do one more. Ready for one more?
Yeah.
Mr. Flack, even though I don't have my paper, I know the answer.
Well, good for you. You have to have paper if you want a Flack attack.
Well, I already know what it is, but I tell you.
Good job for doing it in your head, but if you do it
And I
on
know
a
the
test.
answer's right in my head, though.
Ooh, no. Stumped you. Yep.
Dang it! I know. I don't.
Yep.
Yay.
That's so stupid.
Nope.
That's so stupid.
Yeah.
Wait. Oh, do I get a point now?
Yep. You get a point. So now you're 125. So you have 5 free problem sets you can use.
Okay.
So Kiara, you got 2 points. So you're at 116. Good job. Grady, did you get the answer?
Yeah.
So I'll give you a point because I'm a nice guy. All right. What'd you get?
2 and 7 10.
Okay, let's see what happened here. So what do you do first?
Parentheses.
Okay, so there's parentheses there. So what is that? On the bottom is 10 minus 1, right? The bottom is 9. Yes.
I saw that as 10 divided by 1.
Oh, sorry. Bummer. Okay, now what do you do on top first? Alan?
Multiplication.
Yes, do multiplication first. Don't do 9 times 6. Don't do 9 times 6. Please don't do 9 times. Anybody do 9 times 6? Okay, so this is 4 plus 30, which is 34, minus 7. Okay, so then you get 4 plus 30 is 34 minus 7 is 27 on top. And then 9 on the bottom, which is 3. Good stuff, right? That's lesson 63. Do you guys have questions? Oh, sorry. Avery, did you get it? Yes. No. Oh, she didn't. Sorry. I stumped her. Yes, I stumped her. Okay, let's do lesson 64. You guys ready?
Fine. We're doing lesson 6. Yay!
Okay, 64. We are going to add signed numbers. All right, now we did a little bit of this, but basically we did it like on a number line, and it was for those of us who aren't really that visual and don't really, or that was a little too visual for me. Adding with a number line, let's not do it that way. Let's do it this way. We're gonna have a rumble, and there's only two types of people in the world, positives and negatives. When they get together, they fight, okay? So when you get negatives with other negatives, they join forces. They like each other. When you get positives with other positive, they join forces. But when you put positives and negatives together, they fight, okay? And eliminate each other.
Oh,
So that's what we're gonna do. What happens when you put a -2 and a -3 on the battlefield? What's gonna happen? Yeah, they're gonna join forces. Okay, what happens when you put a +3 and a -5 on the battlefield? What's gonna happen? They're gonna fight. How many? They're gonna win. Who's gonna win? Negatives by how much? -2. So there's going to be casualties, but the people left on the battlefield are 2 negatives. Okay. What about this? What's going to happen there? This is a classic tragedy, right?
We're all gonna die.
Everybody dies.
That's sad.
Okay. All right. So what's the rule? So you can write these down if you forget, but these are the rules for adding signed numbers. Okay, when you add a positive or basically like signs, they have the same signs, you add, right? And keep the same sign. So -2 and -3, you add them together, -5. So really you're not, I mean, you're adding the absolute value, right? 2 and 3 is 5, keep the same sign. If they're unlike signs, what's gonna happen?
They're gonna kill each other.
They're gonna fight, which in math, what does that mean? Subtract. Consider yourself subtracted. Sounds brutal. So subtract, and then what's gonna be the sign? How do you know what the sign is gonna be? Yep.
Whatever one's left.
Yeah, well, how do you
Which
determine
side?
that?
On which side?
Tell me in mathy terms, how do you determine which sign you keep, you end up with?
Was for me, I would stare at it for a long time.
Okay, can you tell me in mathy terms? Yeah, Hunter.
You use your brain.
Yes, you do. But you subtract, that's what we did. We did 5 minus 3, right? And then how do you know that it's negative? What has more what? In mathy terms. Because technically 3 is more than -5, right? 3 is a bigger number than -5.
What has more numbers if there was no signs?
Okay, what do we call that? We just talked about that.
I don't know.
That was one of the symbols of inclusion. How do you treat a number when you ignore the sign?
Oh,
Did you just hit yourself?
I'm thinking. It's
2 words.
I know. I can't remember the 2 words.
First word. Second word. Yes.
Symbols of
No.
that one down. Oh, did I?
I'm still giving you time.
Is that the sign of gender? I swear.
Sign of the greater.
The A and the D are really close, so from back here it looks like it's a D.
Sign of the greater.
Come look from back here. I swear it says gender from
I'm
back
wearing
here.
my glasses and it looks like gender.
You need better glasses.
It does look like gender, I'm sorry. It's the sign of the greater.
I thought it said sign of Black.
That's not.
It's the sign of the mumbling.
Some of the greater.
It's not pretty.
Absolute value. That took us forever.
I know, but it was fun.
No, it wasn't.
So you guys know how to add unlike signs anyway. You just it's the greater one, but technically it's the sign of the greater absolute value. So -5 is a greater absolute value than +3, even though 3 is greater than -5. Would you all agree? Would you rather have 3 pizzas or -5 pizzas?
-5 pizzas.
Then you just threw up 5 pizzas. That's great.
No.
Okay,
Yay.
so I would rather, so 3 is technically the greater number, but -5 is the greater absolute value.
And
Okay?
if you combine 2, you lose 2 pieces.
2 what?
If you eat 3 and throw up 3, you throw up 2.
That makes
If
sense.
you eat 5 and throw up 2? Oh, no, if you eat 3 and throw up 5. Yep, that's disgusting.
Yes.
I don't
So-
know why we're talking about this.
Yeah, that's, now I'm hungry, but not for throw up pizza, for normal pizza. Okay, so, so positive plus a positive stays positive, negative plus a negative stays negative. Positive plus a negative, you can't say whether it's going to be positive or negative until you know which one has what numbers you're dealing with. So it depends on whether the answer is going to be positive or negative, right? Okay, just for sake of argument, so a negative plus a negative is negative. What's a negative times a negative? We haven't talked about this yet, but anyone know what a negative times a negative is?
Number.
Positive.
Yes. That's the weird one. How can that
Would you
be
do mine
right?
instead?
Yeah, so negative times a negative, if you try to wrap your head around that, you're like, why does that make sense? But really, when you're multiplying, you're just adding something a bunch of times, right? But when you're multiplying a negative times a negative, you're subtracting a negative a bunch of times. What happens when you subtract a negative?
It turns into positive.
Turns into positive, okay? So it's a weird thing, but this is what's most confusing about positive and negative numbers. If you can remember this, then you'll be fine. When you add 2 negatives, it is, when you add 2 negatives, it is negative. When you multiply 2 negatives, it's positive. That's the hardest rule to remember with sign numbers. Yes.
It's kind of hard because like on the number line, the negatives go backwards.
Yeah.
Instead of going the right way like the positives.
Yeah, yeah. So when you get to multiplication, that's a little weird. But it kind of makes sense when you're adding still. If you go over 3 to the right and then back 5, you end up at -2. If you go over 3 and then back 3, you end up at 0. If you go over 2 and then left 3 more, then you're at -5. That makes sense. But when it comes to multiplication, that gets really weird and squirmy. That doesn't make sense. But okay, so let's see if you can do this whole thing in your head. Okay, what's going to happen?
That 7 is gonna lose.
7, it almost had enough people in his army to win. Not quite.
Do I have to do this on paper?
No, what do you got?
-2.
-2. Okay, how did you do it? Did you just go left to right?
Yeah.
-5 plus 7 is +2 plus -4 is -2. Okay, anyone do it a different way? Yeah.
I added all of the negatives together.
Yes, that's what we would do if these guys were going to fight. Before they would start fighting, they were like, hey, look at, there's negatives over there. It's Charlie's group from the lower south side. I don't know. So let's go join him. And then we have a bigger army. So what they're going to do is join Charlie's group. So what is that? -9 adding to a 7. So now you just got one fight instead of 3 different fights.
Charlie's gang of negative numbers.
That's going to be my band if I ever start a band.
Charlie's gang.
Game of negative reviews.
Yeah. Okay, so obviously the same rules apply to fractions and decimals and stuff like that. But when you deal with fractions and decimals, for some reason we forget the rules. So if you get a problem where there's fractions and decimals, just remember the rule. So for example, what are you going to do with these? Are you going to add or subtract? You don't have to do this, but are you going to add or subtract these?
Add.
Wait.
You're going to add or subtract those? Add. They're the same sign, right? So you just add. What is that? 5 and 5, 6. Because they need a common denominator, so -5 and 5, 6, right? What about this? Are you going to add or subtract these? You're going to add or subtract those? Subtract. So, okay, so the negatives are bigger, so that's what you put on top, and then you subtract them, and you get your answer, right? -2.94. Okay, so same rules apply, but for some reason when we see decimals or fractions on the page, our brain gets foggy. And that's totally normal. So if you forget the rule, just, okay, I'm going to forget these are decimals and say, what do you do if this is the case? Oh, that's -3. That's right. So you subtract. So sometimes when this is going to confuse you, but let's just rewrite the problem without all this nonsense. Like -2 plus -3. Oh my goodness, that was loud. Then it's the same rule as that problem, but sometimes we need an easier problem to remember the rule. Okay? You guys good?
Mm-hmm.
All right, that's all I got. Well done. Good and faithful students.
I think I-